Hi. In this video, I'm going to introduce you guys the idea of integration. Okay, so we have came across a lot of differentiation, right? We have we know how to find the derivative of power functions, derivative of natural log functions, even the derivatives of trig functions. So we should by now be pretty comfortable with differentiation. Now, the opposite of differentiation is called integration. Okay? So let's just take a look at an example that will show you guys kind of give you guys a big picture, a brief idea of what integration is about. So today, let's say my f prime x is 2x plus 3, right? So this is my first derivative. F prime x is equal to 2x plus 3. Now, what are the possible f of x? So the first one, I have f of x equal to x squared plus 3x. The next one, f of x is equal to x squared plus 3x plus 3. And the last one, f of x is equal to x squared plus 3x minus 2. So let's see which one is, which one of this is a possible f of x. So from the first one, let's go with the first one first. F prime x from here, this will be 2x plus 3. Right? And let's move on to the next one. F prime x is equal to 2x plus 3. When I differentiate a constant, it becomes 0. Right? So the next one, f prime x is equal to 2x plus 3. So we see that all of these three functions, they all have a derivative of 2x plus 3. Right? They all have a derivative of 2x plus 3. So we call all three of this, they are called the antiderivatives of 2x plus 3. Or in other words, we call that the integrals of 2x plus 3. Okay, because when I differentiate this function, the second function, the third function, when I differentiate them respectively, they all give me a first derivative of 2x plus 3. So all of these three functions are the potential integrals of 2x plus 3. Are these the only three possible integrals though? No, right? So we can have, as long as the equation, if a function that looks like x squared plus 3x plus a c, where c is any constant, can be positive, can be negative, can be fractions, can be rational numbers, irrational numbers, whatever, right? Can be square roots, anything. So as long as my function is in this form, I will always get a first derivative of 2x plus 3, right? So this is the integral, the general form for the integral of 2x plus 3, right? This plus c means plus a constant, which means plus any value, right? And that is something that we must always have when we are trying to find the integrals of any expression. Okay, so let's take a look at a few examples here. Okay, so I have three examples here, right? The first one, and what they want us to do is to find the integrals of a, x to the power of 10, b, 1 over x to the power of 5, and c, 4th root of x cubed. So let's do them one by one. Please be careful with the math representation here. So to find the integrals, this is how we write it. So I will say that represent integral. So I'm going to integrate x to the power of 10 with respect to x. Okay, because my variable is x, that's why I put down this dx over there. So I'm going to find the integral of x to the power of 10 with respect to x. That's how I call it. Okay, so in your head, this is the thinking process that you should go through. Now, let's do this in the opposite direction. What do I differentiate? What should I differentiate so that I will get x to the power of 10? So when we are differentiating, the power has to drop by 1, right? So which means the original function should have a power of 10 plus 1, correct? So which means it's going to be 10 to the power of, x to the power of 11. Does that make sense? Now, if I differentiate x to the power of 11, I will get, so I'm going to kind of do this on the side. If I have y is equal to x to the power of 11, and when I differentiate y, I'll get 11x to the power of 10. This x to the power of 10 is good, right? We want that. This is that match. However, the 11, I don't want that, right? I don't want that. So if I need to somehow have something in the front to take care of the 11. So how can I do that? Easy. Put a fraction. Does that make sense? So if I put a fraction, so let's see. Let's do this. If I say y is equal to 1 over 11x to the power of 11. So dy dx gives me 1 over 11, that's still there. The 11 goes to the front, right? So multiplied by 11, multiplied by x to the power of 10. 11 cuts out, I get x to the power of 10, and that is what we have over here. So my answer is correct. So you can always check check if your integral is correct by just simply differentiating it. However, this is the part that that students always forget. Don't forget the plus c, right? Because I can have this plus 3, and when I differentiate that, the 3 goes away. I can have minus 5, 1 over 11 x to the power of 11 minus 5. When I differentiate that expression, the minus 5 becomes 0, right? So always put down the plus c, okay? That is a must. Please don't forget that constant at the back. All right. So now let's take a look at the second example. So I need to find the integral of 1 over x to the power of 5 with respect to x. Right. So this is the same thing as saying I'm going to find the integral of x to the power of negative 5 with respect to x. So before I differentiate this, before I integrate this, I need to think about where did this x to the power of negative 5 come from? So before, the original f of x has to be x to the power of negative 4, right? Does that make sense? So if I differentiate x to the power of negative 4, I'm going to reduce the power by 1, so that's how I get the negative 5, right? But when I do that, I will also have a negative 4, so I need to take care of it by adding a fraction, and then plus the c at the back. All right, so if I just try this, let's try to test this if this is true. So my y is equal to negative 1 over 4 x to the power of negative 4 dy dx. That will have negative 1 over 4 multiplied by the negative 4 goes to the front. That will be negative 4. And my x is negative 4 minus 1. So the negative and the negative cancels out. The 4 and the 4 cancels out. I will get x to the power of, that's minus 1. Minus 5, which is what we have over here. So my answer, my integral here is good. That's correct. Okay? Now let's do the next one, the last one. So this can be written as x to the power of 3 over 4. Right? And they want us to find the integral of this, which means the right now, my power has dropped by 1 already. Right? So if I find the integral of x to the power of 3 over 4 with respect to x, that will be, so I need to bring the power up by 1. So I will have 3 over 4 plus 1. And I need to be careful because when I differentiate this, I'll get a fraction. Right? A fraction, so that will be 1 over 3 over 4 plus 1. So by doing that, I'm taking care of the fraction. Right? So this will be, what's this? 4. This is 4 over 7. Right, 4 over 7, x to the power of, this is 7 over 4. Let's see if that's right. So, if my y is equal to 4 over 7, x to the power of 7 over 4, dy dx gives me 4 over 7 multiplied, so bring this power to the front, I get 7 over 4. X, I drop this by 1, so I have 7 over 4 minus 4 over 4. I will get, so this can be cancelled out. I get x to the power of 3 over 4, which is what I have here. So my answer is almost perfect. Don't forget the plus c. All right, don't forget the plus c. All right, I hope you guys kind of get the idea of how to find integrals, and I will see you guys in the next video. All right, bye.